Secure coding. I'm Kavind Herath. My student number is MH20911058. ETC is assignment 4. Today's agenda: secure coding principles, secure software, secure coding standards, well-known vulnerabilities, trust boundary, securing a programming stack, mean stack security, MERN tax security, net security, Java enterprise stack. I'm not particularly stick on that, just given topics that some more topics that are going to be discussed further. For example, like some of vulnerability examples, and what are the areas where that it's critical for the vulnerability, and not only that, and also some tools that and with examples that how that the especially CryptoGuard like tools, how applied, and what are the difficulties of that. Not only about that, so further hope to discuss about these presentations on and the DevSecOps and some more other the types of frameworks that what directly involving with secure coding principles and secure coding on particular applications and softwares. So then we'll start that today's presentations about the coding principles. That is very common in the secure coding principles, because if any developer quite interesting about these principles, any developer should be stick on those principles, otherwise it won't be a proper output can produced by the developers. So, and especially for these days, not like we're comparing with the last decades, but these days in this current situations, that secure is the main point. Secure is the things that we need to concentrate more and more, and each and every times, not a particular times of the developing or when the customer use that, it's must be concentrate on from the beginning and to continuously practices as the coding, secure coding. Therefore that these principles are very important. Then build up a proper application security, it's in a deed. That is a good principle. So minimize the vulnerabilities. The plenty of way that we can think about, and as a principles that we need to keep that always. We can zero vulnerabilities that won't be possible in a live environment, but to minimize and mitigate the risk, and mitigate the risk of the system and customer satisfactions also. But for anyhow, finally we hope to satisfy the customer, so that all the parts, that all the principles that we applied for the coding systems ultimate reality to become a customer satisfaction and business continuity planning. Those are the main object of the today's that secure coding and such principles. Secure coding principles we can divide into several segments: secure by designing, secure by defaults, secure by communication, secure by implementation, as like the different way that we can define in that the secure principles, coding principles. Secure by designing, from the designing in that we need to think about those principles to establish trust boundary. The trust boundaries is the major topic on that today's in these sessions, and as well as for the developers, because if we have a trust boundaries, only we can believe that there is no any unwanted access, unwanted attacks are happening. So that how I can do it with created the trust boundaries. There are plenty of physical trust boundaries. You can have a software trust boundaries, and as well as the virtual sub boundaries or conceptual trust boundaries can create with within the frameworks. So that of course like we need to become more concentrated. It's an economy of mechanisms that how we can use this one. uh, it's very in simple manner, so that would be the accessibility also should be there. If there is any principles that should be accessible each and every segments of the coding. So that is when trust reluctance. If you're even though but you're not like, but should be a trust, you like or not, that should be a trust. That is why the trust reluctance. Open design should be very open to everyone, uh, without hesitation, so that every applications, because if there is a principles as a coding of the CQs, but that is not to say like that there is only allowing the particular party, means like for any the purposes, but it should be ultimately should be used by the customers, used by some other stakeholders, that is stakeholders that have an ability to capability using this. This is for everyone to see the content. So for this is open designs and minimize the attack surface. It's the kinds of trust boundaries. If we have proper walls, the protection walls, then mitigates the access from the attackers or intruders activities, can minimize from the surface itself. Surface weakness links, secure the weakness links, that we can identify the where the links are weak. We should be able to understand properly. For example, like um, some sort of a ports are very weak ports are there, so we need to decide whether that this port is used or this port is should be allowed or not, or particular people on this allows, like that secure links. If there is any weak links, that you need to be minimized and stop or protected, that one to be uh, design stage. This is the most important factor. Then secure by defaults, by systems, most of them are itself having a sort of a privilege for sort of a security. So we need to just let them to be there as defaults, because some of them are changes into some different levels of the security. So that of course like it's not recommended. Let them to have for examples, like if your guest user should be have some sort of a default security, so don't allow to more and more power as some other restrictions to violating the restrictions. That of course like maybe having a issues that for the future that unwanted access possible to be there in the inside the system. So therefore the secure by default, as leads use leads to privilege. The privilege should be a very little. So user privilege, this is not user, it's doing some sort of activities. You need to understand what the user is using, what for that user is needs to use the system. So that is the first initially understand for access to that one, and to change those particular area, and never allow other sort of a database access or other sort of some SQL accesses or a coding or such and such a unwanted the area. So therefore that privilege levels user is least privilege is very important. And default deny, if the deny is in by the default for the user users, we do let it be there as it is, to without any changing if any special circumstances fail securely. Yeah, of course, sometimes maybe, yeah, acceptable if there is a failure. Yeah, because this is still sometimes may area where we can identify having some sort of issues, failures. Yes, but that should let it do be there as securely fail, right? So that's the way that it's a fail secure. And the next principle is the coding secure by communication. Secure trust relationships. Secure by communication, secure trust relationships. That of course like the relationships between different applications or different the segments of the developments that should be having in a within the trust, right? So secure by implementation. By the implementation should be a secure some sort of areas, but not the latter part of the implementation. So that is secure by implementation uh, during the process time. And psychological acceptability, there should be the way of that accept whatever the issues comes from the systems, or a secure or unsecure or kind of a things. So sorry. So psychologically it should be acceptable, and least common mechanism least common mechanism. So don't use like while during the implementation, if you need to secure, very common, even though sometimes that very common the one very common the coding methodologies, don't apply this one. And also check whether that is the latest applicable the rule and regulations. So because the common one having a common vulnerabilities everywhere, so to protect that one you must use the very unique and validate inputs. We need to be validate inputs, secure data inputs. It should be there to secure the data whatever that is to input to the system. Prevent bypass attacks, always audit and verify. And defense in depth, it should be always to keep the defense. Secure coding principles further, we can just elaborate it like vulnerability implies weaknesses that of course having from the fault in design or developments or configurations, we can either wherever that vulnerability could happen. So that could be a violations of our security policies in the organization. So therefore we need to minimize, mitigate, avoid, get rid of the vulnerabilities implying to the system. That is why these principles are coding principles are very important for us. And also the vulnerability is common vulnerability. There are some plenty of common vulnerabilities, but common vulnerabilities are that means that we already being identified, some coded standards are identified that now these vulnerabilities are in systems existing. So but the non-vulnerabilities also, some of them are again exposed to the security threats as a security threats. So sometimes you may not intended or unintendedly or intentionally or intentionally you're doing like such errors. So you need to avoid that while stick on the principles. There are many benefits to secure coding principles are there. It's not only one, there are plenty of the benefits that can used by the developers, users, customers, or ops teams or SecOps teams, everyone. Secure coding practices find remove vulnerabilities that could be exploited by the cyber attacks from ending up in the finished codes. Can avoid all the, if you good practices, avoid the vulnerabilities. That is one benefit when you stick on the principles automatically system by itself, or if you're move forward with particular principles that is you don't know but it's already avoided by developing secure codes. Cyber attacks will find it difficult to hack the code and gain access to the applications and systems, thereby reducing data breaches. The data breaches are reduced by automatically if you stick on the principles. So that is why if you're without the principles, if you're doing, you don't know whether that your software system is protected or not, but you may have 100% sure that your system is, that your coding principles are, your secure coding principles are. If you're intended to that these practices, what happen, ultimate result is your system is already being secured. The security architectures are very important factors to be think about the secure codings. There are plenty of standards architectures in that you need to go ahead with. But sometimes you may get in the license, and sometimes you may have some sort of a extent to use it. If you use that, you should be get the license. However, that is very important to know about that, those the security architectures and the frameworks. Very popular architecture NIST security frameworks. It's been many years, 100 years experience with the related and unrelated industries about the security. And even though like last 50 years from USA, that be government approved institutions about the security frameworks, so therefore well recommended. And also this is the framework which is very directly, without any complicated matters, we can apply this NIST security framework. So I will show you that this framework, how it works, the importance of this, the NIST framework. Right. So however, but so having some sort of a difficulties to this one. Later on, later part of that, I would more discuss about this NIST security frameworks. And there are some plenty of that Jericho security models, security architecture, landscape, and software assurance maturity models, and security within the SDLC process. ISO IEC 27001 security architecture is there. COBIT security frameworks are there, but those frameworks are a bit complicated comparatively NIST. The applications and the deep end process. Secure coding best practices. Again, the principles we already discussed, the same, the principles. The coding best practices also sort of the principles, but you need to do it in the good way to keep that your codings are secure. Secure by design, password management, access control, error handling and logging, system configurations, threat modeling, cryptographic practices, the good practices of the cryptographics, because there are plenty of error or vulnerabilities are there on cryptographic practices, because this is a little bit complicated analytical mathematical concepts. Most of the developers is not deeply understand the what this process happening. They might sometimes think it is just English words, this or AES, what sort of a the maths or logics is more suited for high security or hashing function. So that is of course like it's a best practices. You need to know about this, or you need to get advice from the security engineers. Input validations and output encoding, those are the best practices. Frequently, again and again, need to concentrate on the developers. What is secure software? It's no any doubt the secure software has developed with the secure procedures. Secure procedures, we need to develop that as a secure procedures. What secure standards, use of the secure standards, use of the principles, use of best practices. Those are the procedures to behave a well formal, will continuous functions, even the circumstances as such malicious attacks. That software should be continuously functions without any issues, even though if there is malicious attack, then that software well secure software, well secure application. So that is why the definitions of the secure software. How to secure security or software? So then the managing access control, providing data protection, and safeguarding against the virus and other cyber security vulnerabilities. Then we can ensure security software. Right? An essential part of the security software is the secure coding and using the right software security tools. Software security tools again come into the fields at this moment, because if you know that while doing the software codings, you know some sort of issues, errors are there, can you do it? Can you capture the human brains or um, on particular errors? No, that could be is not possible. That is why that there are some again particular tools we are use for this one. That is another some sort of a tools that which is related to the finding some sort of issues, vulnerabilities in the systems. So we need to stick on that particular well, software tools to identify the errors coded in the codings. So for example, like, so we can just go through about that. Particularly tools, right, which can be used for as a finding the issues or codings, right? So then it shows like having some sort of a secure coding methodologies to identify. It's called the CERT. So that is all the methodologies that you can identify that particular issues. First, particularly, it's that already mentions are coding standards that supports to common use processing use programming languages such as C++ and Java. But C and C++ are not very common, and these days to the development methodologies. But it's still being using, and the Java is the most the majority mega projects are handling. So that then secure coding methodologies that we need to use as a CERT, secure coding importance. Then that there are plenty of methodologies to be applied if you're doing the secure codings from this. And the what is this SAST, as I mentioned, all about the static application security testing tools, is an application security technology that finds security problems in the code of applications by looking at the application source code statistically, as opposed to running the applications. That we can, by looking that it's running the codes that SAT is given the specific area where that this is the area where it's going to be some sort of issues. So that is the way that it's SAT is. Also there are three different three different approaches. One is a SAT DAST and IAST testings. Those testings are very important to carry on simultaneously with the developers, with the codings, to identify the vulnerabilities or issues that can arise in the coding systems. That those practices are very important, and that the SAT-like tools is given the many of guidelines that how could you do and how could you get the well-known the coding issues from the system. So that of course developers need to know. Due to these critical limitations, static analysis tools are being replaced by IAST approach, more modern approach. That is, the IAST is a modern approach than the SAT. So because of that issues and that sort of the weaknesses that identified on the SAT, and will develop this IAST. One of the key strategies of SAT tools is broad coverage of programming language and development platforms. So many platforms is maybe support, so that is the advantage of the SAT. Still, that the secure coding standards are intended to practice result-oriented rules and guidelines to prevent vulnerabilities. Very important, this saying again, I will say the secure coding standards are intended to practice result-oriented rules and guidelines to prevent vulnerabilities. That is the secure coding standards. There are plenty of key secure coding standards are available. Secure coding standards are available to be to good practices for the developers. There are plenty. For example, CWE is very common. CWE top 25 common weaknesses, emulations that already developers need to know those steps, those the keys, what are and there are some sort of issues and the vulnerabilities, weaknesses that introduced by the particular areas. For example, so and if you want to go through that the sites, you can just click on the sites and see whether that what are the all the CW common weaknesses emulations. It's already mentions by the software and hardware the research, like all the way that they can get the whole the sort of a descriptions about for particularly if you need to have some sort of a API application program interfaces that are very important in the development in the coding and the softwares. So so about that you can just go through that many of the details and the developers and about the developments and software development, what they should know, what they about how to do it, and rule and regulations what they, and the weaknesses, especially for what sort of a weaknesses are availabilities. So then for the developers that point of view, that these CWE common weaknesses emulations are very important, the valuable source to study, deeply read that each and every point. So before you start that your development the era. So and errors, some sort of errors, that what sort of errors is can identify the list out those authentication errors, that then it's maybe very helpful guidelines for us to, for the developers to especially to going to stick on this one. And this we already discussed about this here, right? And about that tools, so how that standard key tools. And also the next one is CVE, um, and as well as the NVD also having a US government and as well as NIST calculate NIST tools to use it, matrix. So actual vulnerability matrix. So this is very popular among the most of the developers, and it's well standard, well practices the to be used by the developers as a, the key points. And as well as this one is having given like you need to be have a uploaded that sort of a program, whatever that your programs to into here, then they will give you that some certifications. It's not exactly the certifications, it's give you some evaluations about that you're coding the practices. If there is a sort of any vulnerabilities, they can list out. So then you may have some sort of a confidentiality to go ahead with that your coding standard. So therefore this is very important for the developers, that NIST has introduced to this one from here, having a there are plenty of vulnerability matrix, and as well as the vulnerabilities you can evaluate on this one, right? And detail pages also, their vulnerability status or status they have given, if or whole sort of a status as like this. These are the status on that particularly that you are coding what you have made developed. So what they are doing is like they clarified according to this given the chart. So the receiving and the waiting for analyzing, just analyze it, and if there is some rejections, that rejected is given rejected rate or whatever, that all will give you as a report. So therefore that standard, this is a very important standards comparatively, because this is already being NIST, it's US based the standard there. And DISA, STIG and OWASP. And the second one is this OWASP standards top 10. Also the very important for the developers to well known these standards, because why this OWASP is the well organizations that has been developed for particularly for the development of the source codes and their vulnerabilities. Top 10 is that very common the vulnerability list, and has given for this the OWASP whole sort of a from mainly from that from this top 10 that's well known vulnerability top 10s are introduced, and they already defines this, but you can avoid them, you can mitigate them doing those doing practices. So that is why that's very important. This OSAP, its vulnerabilities, OSAP organizations. They already propose us to that to do its best practices by doing this and this security measurements. So then you can avoid that those sort of vulnerabilities. So therefore, then it's very important that to practice the oral will learn about that the OSAP here key coding standards. And as well as like there are other plenty of standards already being here with us to further studies. And also cryptographic model validations programs, also there are cryptographic models, especially this is for particularly for the cryptographic also. While doing the coding practices, that cryptography is doing the huge part of that one. So that is also NIST has to introduce that the cryptographic model validation program. For particularly, you need to be concentrate on this while you're developing the good output of the program. So that's why. So they introduced like FIPS 141 and 142, 143, three validation modules, three modules to introduce that to be have like to overcome the some sort of cryptographic vulnerabilities particularly. So therefore, that is why this is very important to developers to know about that. If you're well knowing on these particular things, that then you can have some sort of a get rid of that the particular vulnerabilities to do that some well improvements cryptographic improvements of the cryptographic coding systems. That's why it's just already mentioned on these particularly those standards. Elements of secure codings. There are particular elements in a secure coding. Sometimes we discuss about this one, but mainly it's their architectural principles there, the rules that will apply with equal force across a wide range of platforms and applications based on psychology, experience, and computing theory. The architectural principles should be there. And design ideas, that should be a design, great ideas, details, technical advice that can nevertheless be applied to the many different language and operating systems. Language specific tips, especially for this language, Java language especially, or Python, there is a particular, C++ particular, derived from particular language features. All are included as the elements of the secure codings. This is some sort of a well-known, the vulnerabilities introduced by the codings here. And this buffer overflow is a well-known vulnerability. It's in practice every day. So in these coding mechanisms, you can see that the buffer 2, the arguments of this copied into the buffer 2 without checking its size. This flow introduces buffer of vulnerabilities. The copies into the arguments is copied into buffer 2. Argument is copied into this buffer 2, right? Without checking the size. Then buffer overflow, because there should be a particular limitation that to describe. Otherwise, what happens if that is, of course, like in a huge, that all things are copied to that one. That may be in trouble. Ultimate result is there is no any particular space for go ahead with running the program. That's of course. The second scenario is just integer overflow. That integers are running again and again, as it such earlier. Earlier is the memory, so then now its integers are overflowing in this program. We'll see that if the number, integer variable number, many continuously create smaller values than the max now. and would result in an integer overflow. This scenario will also overwrite maximum 1 bytes of buffer. So that of course, like, it is then this maximum 1 bytes of buffer, it's having to overflow in this scenario. For that means an integer, that if your count integer is in a overflow this short coding program. So that is why. But if that something is already being introduced, that here is there is some sort of the vulnerabilities, then for your the point of view is the best practices later on. This is where again that it's very common and the well-known vulnerabilities introduced by the coding. Cross-site request for 4G evil site. This is very common and most of them have some experience, but unfortunately the victims may having some more suffering, so more the wasting their the money or sometimes the values assets. So how it will work is that if there is a trusted website is available, so victims needs to browse this trusted website. So he requests, and with his log the genuine credentials, the username and passwords. So but what happens to that evil site, right? So what happened, evil site, they will but victims to web browser is the access to the evil site either. So they will take an advantages of that this evil site and the cookies. However, but it's trusted site is sending the cookies, that cookies taken from the evil site, and they will respond it. They will request as a genuine user given particular username and passwords, and they will use the benefits from trusted websites to evil site. So however, if unfortunately these victims is suffering, but the evil site, that hacking party will take advantage and they take the whatever transactions that hold the authority by them. So that is very sad scenario. So it's happening currently. This is cross-site request for it. A cross-site request, this is the scenario it's happening. The cross-site request for IT occurs when an end user is forced to execute unwanted actions in web applications to which he is authorized. All web applications that use persistent authentications only, cookies or sessions identifier, could be vulnerable to such an attack. By conducting these types of attacks, the attacker can execute all types of actions that would benefit him. For example, transferring the funds from victims' accounts and tax on accounts. That's the worst scenario happening, particularly this one. Just to brief in on that, the attacks vectors. The many attack vectors is not only one, hundreds attack vectors are available. So sometimes it's most popular attack vectors. It's just mentioned here. For example, lives well known. We can take cryptographic performance attacks, cross-site scripting in AJAX, clients validations in AJAX routines, HTTPS interceptions, GUI intersection tools, like such as many more, like here spoofing attacks. So like some, right? So very common attack vectors are there. Trust boundary. So what is the trust boundary? So if you need to protect that your applications, that you should have a proper trust boundaries. From that trust boundary only, that you can protect that your applications. That should be with outside or inside both, because we can't say that vulnerability is from the outside or the vulnerability come from the inside either. So therefore, that your trust boundary should come from the outside and as well as inside. So to be protect that your applications that inside. So what sort of the trust boundaries that we need to build up it's maybe the challenge. It may be a challenge. Sometimes it would be a physical, sometimes it would be the virtual or applications. So physical, I can say that it's the firewall. It's very popular among us to have create a trust boundaries, and not only that, but in the physical structure of the network, I can further can just to elaborate, like such as the sandwich layer of the layer 2 would be possible to have some uh, attackers to breach to the system. So that is the trust boundary that what we have. So if you have a like a sandwich layers before that your routing access, that would be great, that would be fine. So that is the trust boundary from the outside, physical, right? And restrictions, rule and regulations. Not only that, then it should be some sort of cryptographic protections to read and write, or CIA especially, confidential integrity and availability. The concepts, if possible, to protect from the cryptography. That is the fantastic. That is that expected from the stakeholders to be done in these systems, to by the developers, to before you given to the application to the the users. So that's why here the trust boundary. This boundary drives through the correct directions of the secure software developments. It could be a software, hardware, or even the physical boundary to have proper protection mechanisms. The firewalls is the main actor of the trust boundary builder in between several hardware, several and other network systems. There are several mechanisms applicable for the trust boundaries. Examples we can get at the militarized zones was the concept applied to keep some trusted, untrusted servers. Demilitarized zones means actually it is the zones where that it's not involving any the war activities or in trusted activities over there. So therefore, if that there is a server is not much is relevant to the trusting environment, so then you can keep that song. So that is why DMZ songs such as. So this is the socket's environment like. Then from these trust boundaries are very important for the socket environment, because each and every links can have some sort of a communications to API applications. Then should be build up the proper the boundaries, the trust boundaries. Here this is many attack sectors are there. We need to identify where that the attack vectors are there, and you need to build up the boundaries, so trust boundaries, each and every segments to be recovered. So then only you'll be in recovered and well protected. So that is why it's a challenge is for us to have like it's modern technologies, the modern environment, that the plenty of way of accessing the untrusted networks and currently. So that is the major challenges that we have as a system engineers, as a security engineers, to fulfill that requirements of the boundaries. So that is not the one, it's not the way one way having doing this is some sort of a design. So while your design view, that point of view, you need to design the systems in deep and properly how to protect the create and the trust boundaries. Input validation trust boundary requirements also there. That is the inside protections. For examples like input accepted from any connections on port 8080. Input accepted only from unknown IP addresses on port 443. Vendors are required to use SSL, secure socket layer, is a must. Data is not assumed to be in any forms. All payments cards and must be in a SSL, not other secure methodologies. And credit card data is masked by the firewalls. Those are the regulations, those are the boundaries, the requirements that should be configured in very as a principles in a developers and software engineers or security engineers to be protected the systems, the without opening to the outsiders. Then only that we have some sort of courage to and decide like this our system is well secured. Min and Man stack, that is of course like it's the latest, I would say like it's latest technologies to be applied for the developers and programmers, and convey the proper technologies, because the technologies are coming now day by day, because the security is the main concern. If anything you and you're developed, then while developing some the development stacks, what happens, so they will already embossed inside the systems on the security, the stacks security, the principles. Then therefore the developers is not much have a headache on the particularly for the security, because already stacks is protected by the security. So that what you want to do is that they need to select the proper secure stack to use it in their developments. That's very simple. It's not the huge big deal. That deal is over. So that's why that it's already being now Min and Man stack. The most of the today's world's web applications are designed using the stack of various technologies. These are the technologies they have been using. Two technologies, Min and Man, are two of most popular and externally powerful stack that are used in the developments, DevOps. Uh, and there are some individual features of it's both uh, available. Choosing between the main stack and the main stack mostly comes down to the developers. That developer choice is to select according to their point of views that are with some their capabilities to use that which system by using by them. Like it's already being developed with that unique mechanisms to deal with the clients and the retrieve data from the particular databases. So that's the way, but they are while doing this the mechanisms of mean stack security is already mentions here. So how that it will work on that. So because uh, directly not handling by as a previous, but there are some the particular the breaks, and they will have some sort of uh, evaluations of particular data on particular area, and then only pass through that the different segments. Before that they will directly deal with the retrieve the data. That is the stacks are there, different stacks segments are divided to buy to the protect for the data security points of view. So then when it comes to the security, then mean stack is secure and stable platforms. MongoDB, a non-relations database, is not prone to SQL injections, as the data is stored as JSON objects and manipulated by SQL strings, which opens the way for robust database security. Then the term in stacks refers to a collection of JavaScript-based technologies used by to develop web applications. That is completely is on the JavaScript base. Main is combinations of the open source. That is a combination of the open source and the general components. Altogether provides an end-to-end framework. Dynamic web applications. And MERN stack security. MERN security applications scalable, easily integrated with the security DevOps environment and hosting provides. As we mentioned earlier, that this is inbuilt with the DevOps systems. That means the MERN stacks is excellent choosing for companies within to develop high quality web applications. That is why our expectations meaning is scaffolding tools which makes it easy to build universal apps using Mongo as such, that those are having a security inbuilt and they can use it. There is another Java enterprise stack is again the Java is the main source of web applications, web developments. So therefore Java having a special stacks now, it's me is reach to in this level with high protection. So that of course like developers being using now currently used under the container architecture names the Java Enterprise Editions. That is a container architecture. Do you know that it's the container architecture is the given more and more virtual environment platforms, and the virtual platforms is given more secure than the physical platform. So that is why it's most of the developers, the most of the stacks and the software uh, develop with the container platform. So that is why this Java Enterprise stack is different than the previous versions, containers to presentations. So are developed in software components. Java Enterprise stacks its terms of Java EE. There are two types of containers: a web container and application. Two containers types are available in this Java stack. So that is a web container and application container as mentioned here. Java container is to look like is this Java EE 5. It is completely same as the virtual container platforms. So because that there is no directly deal with the hardware platforms, this is dealing with the Docker like this, the virtual platforms, the hypervisor platforms. It's not a hypervisor actually; it's a Docker platforms. So then what happens is that particular applications are running on the particular containers. So then of course like having the different containers can deal with as the same features as the container platform. So it could be having a backups if there is any system is down, so having some virtual platforms can share in. So that is Java container BMA expected to develop. So this is the good generation or changes with new generations, new era for doing the developers. The generally containers do is what the containers provide essential services to components and execute the life cycles of components. Samples for provided service by containers. Security. The high is security is more high. However, transactions management, life cycle management, request dispatching. Those are the management. The strategies can apply for the containers. So these strategies are given high. The source of development platforms to the developers. So a little bit I'm going to be changed from in these presentations onwards. Like this is having some sort of the statistics shows that the critical infrastructure of security critical infrastructure. So it's given some IEEE security presentations. So how that they are identified, like the percentage of that particular threats or some sort of a threats activities, it's in common. So it shows that. So we'll comparatively 24%, it's a high remote code executions. Remote code executions is very high percentage, and the 12% of buffer overflow and 17% of information disclosure protections bypassed is also 10%. So that is why the percentage has given. So some of the SQL injections, cross-site scripting, privilege escalations, and path traversal also some extent, but it's not much impact on current situation. So that's why we just want to know, like, while developers to that the issues. The term 10 secure coding rules, just I brief it again. What are the rules we should be able to have this one? Sometimes I discussed about this one in the beginning, from the beginning of my presentations. However, but I just need to brief it again. Validate input from all untrusted data sources. Head compiler warning and other warnings. architect and design for security policies. Keep it simple, default deny, adhere to the principles of least privilege, sensitize and sanitize data sent to other systems. Practice defines in depth. Use effective quality assurance techniques. Adapt secure coding standards. Those are standards. Those are the good practices that I sometimes may say the principles of that. However, these are very important for the developers to be stick on, particularly for this one. And what is a cross-site request forgive 4G CSRF attack? So just earlier that I already mentioned that a brief on like how these attacks come from and how it's that the victims are supposed to be have attacks their attack the their genuine customers to website the bank accounts. As the same here, it already mentions that the 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 browser automatically attacks the sessions ID. The browser is like attacked by the hacker's browser. So in this sort of things that it's already mentioned in that the IEEE security development presentations as well. And for example, so I got the secure on or insecure, secure and insecure. So where that is in the codings, where it's secure and where is we can say that it's insecure. Because if while you're comparing with these tools, we can see that these codings, the insecure is where insecure is HTTP here and HTTPS here. If HTTP means like it is no secure channels, is not secure the protocols, therefore these protocols through if any deals, that means it's maybe privileged to access to the hackers, therefore then it should be as a practice as HTTPS. And secure in this one, well, comparing, so where it's that here a random generator and new random. Here the random is the vulnerable codings, because why? It should be a secure random. Now latest, this is been for a long time used without any security concentrations, but now at this moment we should be used to use as a secure random. So that's the the secure and insecure one. Insecure for insecure in this scenario while comparing this one. So of course like here of course like the cryptographic technology, how that the cryptographic is used, MD5 is SHA-256, it's high protection, the cryptographic algorithm, then it should be the SHA-256 is a high secure, MD5 is not more having a more secure cryptographic algorithm. So therefore that sort of the security measures that secure, you should be more concentrate on that while doing the secure codings. And develop needs tools and more tools, because tools are the elements of or weapons of the developers to be faced the difficulties what will come through the outsiders. So that's why the many tools are there, and you're in a secure. If you don't use that many tools, that what happen ultimately that you're exposed to the systems, exposed to the vulnerabilities. So that would be there. And according to that, this one, so verifications and implementations and design those stages are very important, especially for the implementation and verifications. Tools should be the main part of this development process. The CryptoGuard tools, I just brief about the CryptoGuard. CryptoGuard is what? The basic aim of the CryptoGuard is to detect the vulnerabilities of pre-detectable secrets which are inherently insecure cryptographic key and passwords. So insecure cryptographic keys and passwords are there, then CryptoGuard is the the tools that which is to use to identify. We need to use this sort of tools. As a subsequence of the vulnerabilities such as improper customizations with Java secure socket extensions, API could be security breach of man-in-the-middle attack, SSL or TTL, if the cryptograph is not practically applicable. So cryptography is not, it's not just a small concept. It's a very complicated, rather, I would say, like, it's, well, comparatively, this cryptography is not a simple concept, but it is a well protected systems to be applied. So we will know as a developers, to you or system engineers, that about from the rule and regulations what that behind on the cryptograph issues detections with the cryptograph. It is static tools. It's very common and very popular among the world in the developers to be protected. And there are some other the tools, but this is I just to mention because of it is the very the important crucial the one for us. So there are some the ruling behind that we want to know these static analysis tools. But there are some challenges on this while using the cryptograph tools, as I mentioned earlier. So there are some pros and cons on these tools, especially for due to the complications that it already mentions that a different source, the false positives, and very well the plan and analytical skills are included with this particular cryptograph tool. So that is why just I already been mentioned in these presentations, also highlighted to be used. But it's indeed like if clarifications clarified so that a particular area where that it's the mistakes it has been done. So this is it's very well the cryptograph it's very well integrated tools to identify the issues. And for the development process, that development CQ cycles and DevSecOps is doing the very important roles for the developers, because DevSecOps is the security is inbuilt for the development process and the operations. All the three segments are linked together: DevOps, development, the security, and applications. So that's why informations or development operations both. So this is a good combinations that currently to be applied by the developers to and recommend for that one. So for the DevOps development process, but because and also but it is not the single application process. It is continuous. There is no never end. It's from the beginning to end, and again begin everywhere. If there is any place that it's having some sort of issues or vulnerabilities identified by system itself, so automatically it will identify the issues and it will given the particular message with particular applications, auto running applications. This is completely auto running applications. That means like it's a robotic the methodology that's the DevSecOps in by meaning of the words. So that's why it's for the developers are given the huge impact for this DevSecOps, and as well as they're given some relax to breathe for with this headache difficulties and the criticalities of the systems rather, but they're quite for the developers. So that is why this is DevOps is to very well recommended and having more benefits to, because I know it is not the one dependence. This is a plenty of dependencies, plenty of applications are depend on that, especially for the virtual environments like Docker and the Kubernetes. Everything is already being in the deploying stages to given that automated the solutions and the backups of the systems and the testing systems. So that of course that all the integrations part is Jenkins, like some the applications are doing some integrations and keep the backups to development helps. Planning part is the GitHubs is given to fully support. So this is the complicated process to given segments twice and simplified to each and every, and the continuous monitoring is a very quite interesting part of that, this the DevOps because it's already being alert on each and every time what we expected for the developments or any situations in the software development. So that is why I just to mention is that if you need to have a proper coding or secure coding principles to apply, this is jobs is that to be intended to do it in such a scenario. So DevOps is the continuous development, continuous testing, integrations, developments, and learning and monitoring. That's the fantastic, marvelous, the characteristics of the DevSecOps. And however, but it's today's the presentations I have already been given that fully they covered in some most of the principles of the secure codings, and I just already have defined that the each and every area where it's already been depend on that, particularly for secure coding principles and how to keep that your coding systems are well protected. And thank you very much today's presentations, and also but I learned a lot about the codings during my presentations, and we'll meet on that next presentation. Thank you very much.